Welcome back, everyone. In the last module, we learned mostly about memory and coding. As you'll remember, there are 3 stages to memory: encoding, getting the information in your brain; storage, keeping the information in there; and retrieval, pulling it out for useful purposes. So for today, we're going to focus mainly on the second and the third: storing the memory and then retrieving it. So let's start with memory storage. First off, where in the brain is our memory stored? There's no one single part of the brain where is our memory center for all types of memory. Right? We learned about the hippocampus in the biology unit, which we'll discuss today. That's a storage place for some memories, but memory information is really stored throughout the brain. So the hippocampus is for our explicit memories. All right, let me just get our marker here. So for explicit memories, those are stored largely in the hippocampus. Explicit, you hopefully remember, are the memories of things that we've done in our life, called episodic memories, as well as facts and dates, called semantic memories. Remember, as a quick review, remembering that Barack Obama was the last president would be a semantic memory. Remembering where you were the day of his inauguration, that would be an episodic memory. You remember that experience. But in both those cases, both those types of memories are subcategories of explicit or declarative memories stored largely in the hippocampus, which we know is part of the limbic system. Amnesia, memory loss, often is caused by or correlated with damage to the hippocampus. If there's damage to the left side of the hippocampus, people may have trouble with verbal information, and with the right side, people may have trouble with visual designs and location. And that makes sense. This should not be a new piece of information that you are studying and memorizing from scratch. We know the left side of the brain, right? Left is language, and the right side of the brain is more artistic, abstract, with visual things. So sleep helps. For those, if you're cramming for a test, you're studying for a test and you have a choice between getting 4 hours of sleep and studying a bit more, or maybe getting 6 or 7 hours and studying less, it might be worth it to get the extra sleep, because sleep actually helps condense and consolidate all the information from the day's experiences into our long-term memory storage. The cerebellum. We learned about the cerebellum in reference to balance, and it does play a role in balance. It also plays a role in implicit memories, and that makes sense. Those two things go hand in hand, because what are implicit memories, right? We said in the last unit, and you should know this term is again now, are called procedural memories. Most implicit memories are procedural. Think about a procedure. It's doing something. The procedure of walking, of riding a bike, of dribbling a basketball, of any physical activity. Those are procedural memories. So that's not in hippocampus. That is stored in the cerebellum, which makes sense because that's where our sense of balance and movement comes from in the first place. If our cerebellum is damaged, we may have difficulty balancing how to ride a bike and also remembering how to ride a bike. The other thing that's stored in the cerebellum are classical conditioning memories. We learned back in the learning unit that classical conditioning happens unconsciously. So it would not be in hippocampus. You don't explicitly remember that, the dog does not remember that it's supposed to salivate in response to the bell. It just kind of happens automatically. So these automatic implicit memories are also stored in the cerebellum. The basal ganglia, in terms of, is very similar to the cerebellum. You will not need to know the difference between the basal ganglia and the cerebellum. So I'm just going to put them here together. Basal ganglia, cerebellum. For our purposes in AP in intro to psych, they're essentially the same thing. They both help with implicit memories. They both help with procedural memories, which basically is muscle memory, learning how to ride a bike, remembering how to ride a bike, all those types of things. So again, procedural memory equals muscle memory, and those are all categories or subcategories of implicit memory. All right, so this is going to be some more review. We know about the amygdala. We've learned about it in many units now. We know it's the emotional center of the brain. We know it's also in the limbic system, right next to the hippocampus. And so what you might not have known is that when we have a very emotional experience, whether it be a big high, like, the moment you open that letter and find out you got into college. Actually, do they send those as letters anymore? Or maybe it's via email these days. But when I was a kid, it was still via letter. But when you find out you get into college, or you win, the championship game in basketball or football or whatever, or it could be a very negative experience, right? If someone passes away, or you're in a car accident, or something very tragic or traumatic happens, whether we're excited, stressed, really happy, really sad, any extreme emotion is kind of like sucks all the energy out of the rest of our brain. Hormones make more glucose available to fuel brain activity, signal the brain that something important has happened, and disrupting the memory for neutral experiences at the same time. So you probably don't remember, what color shirt you were wearing when you found out you got into college, or what color shirt you were wearing during that, what was going on outside the car during that horrible car accident. You were just focused, rightfully so, on that really amazing or really terrible experience. And that leads to this phenomenon called flashbulb memories. Yeah, when you think of a flashbulb, it's this one moment in time. It's a very, and it doesn't have to be like a split second. It could be a few minute period, even a few hours, where you remember in amazing detail everything that happened during a really significant event. It could be a significant event in your life, like, if you get married one day, for 20, 30, 40 years after, you may remember exactly what happened at certain points, of that ceremony. Or it could be a worldwide or nationwide event, like 9/11. All of you were too young to remember 9/11. You were probably infants, maybe one or 2 years old at the time. But I remember I was in 11th grade during 9/11, and I can't tell you much about what happened on September 9th or September 10th of 2001. September 10th, 2001 was a regular Monday school day. I have no recollection whatsoever what my schedule was, what I was doing, talking to my friends. But I can tell you, on September 11th, 2001, that Tuesday morning, I was sitting in a student class assembly when we heard the first announcement about the planes crashing. People didn't believe it. People were even joking at first. It was just hard to wrap our minds around. I remember sitting in gym class when the principal came over the loudspeaker and said that both towers had collapsed. I remember everything that I did the rest of that day. That's an example of flashbulb memory. For people older than me, perhaps your parents or grandparents' generation may remember the JFK assassination the same way, where they were when they heard JFK was shot. So those are examples of flashbulb memories. All right, so now we're going to go into we've talked about a bit of biology so far today. Most of the biology we discussed should be reviewed to you. We're going to talk about one new area of bio called long-term potentiation. I'm going to read the definition first, then we'll explain. An increase in a cell's firing potential after a brief rapid stimulation. And it's a neural basis for learning and memory. So I'm going to show you a picture on the next page. It's an increase in the number of receptor sites. So think about, again, this is why this neurotransmitter unit was so important. Think about when the neurotransmitter crossed the synapse, there's now more receptor sites for it to go to, thereby it speeds up and facilitates, makes easier the transition from one neuron to the next. So let's look at this picture. In picture A, this is before LTP, or long-term potentiation, takes place. Here you have this is the axon, this terminal of one neuron, and the dendrite receptor of another neuron. Here, we actually have, it kind of splits. We have two things here in the bottom. This is the same neuron, but the receptor sites have doubled. So it makes it that much easier for the information to get from neuron A to neuron B, because think of it like a highway. Think of it like a road where there's only 3 lanes of traffic. The cars are going to maybe get stuck in traffic and congestion. Then let's extend that road. Instead of having 3 lanes of traffic, Now we'll have 6 lanes of traffic. The cars are going to zoom by. Oh, what did I do there? The cars are going to zoom by so much faster because there's just so much more room to go. So that's what happens in our brain. The more we learn something, the more there's actually on a neural level, there's more receptor sites that are formed, and it makes it that. And then for the future, you've laid the groundwork. For the future, when you learn to review that same subject matter, there's more lanes of traffic in your brain for the memories to go, or the new information to go from point A to point B. So again, with long-term potentiation is this biological neural basis that doesn't just say studying makes you smarter. It says studying actually makes your brain more available to make you smarter in the future. It lays the groundwork for your brain to have more resources to provide for you. Okay, we'll go over that more in class. So this is a summary of everything we've done yesterday and today. Generally, implicit memories are automatic, right? They're not things we're consciously aware of. We said cerebellum and basal ganglia. You don't need to know the difference between the two of them. We talked yesterday about like how you automatically just kind of just know where you are and approximately what time it is without paying attention to it. Muscle memory and classical conditioning, right? Those are all things happen automatically, implicit memories. Explicit memories, we say these are in the hippocampus and to some extent also in the frontal lobe, but primarily hippocampus. And there's 2 main subcategories of these explicit or declarative memories. They are facts. Facts would be semantic, right? Facts about general knowledge. And personal experiences, right? These are episodes in your life. So I can't fit all in there, but like episodic memories. Okay, so that's recall. That's storage. Now let's talk about retrieval. So there's different types of retrieval, and it's much easier to recognize something than to recall it. In other words, it's much easier to do a multiple choice test than it is to do a fill in the blank test. So because you already have retrieval cues in the multiple choice test. I know it's definitely not A, B, or C, and D actually looks kind of familiar, so I'm going to go with that. Relearning is a measure of memory that assesses the amount of time saved when learning material again. So if you took, the biology test back in October and I gave it to you again, I'm not going to, don't worry, but if I gave it to you again in March, you would probably need to study less time than you had to originally because it's already still in your brain, even if it's not super fresh. So priming, this is one of the reasons why recognition is easier or better than recall. Priming are external cues that activate our associations, helping us retrieve memories, and this process often occurs without our awareness. So if you see or hear the word rabbit, you then think about rabbit, and then if you're asked to spell the word hare, right? Hare is depending on which hare you mean, can be spelled 2 different ways. You would spell it H-A-R-E. If someone was not primed by hearing the word rabbit ahead of time, and you were asked to spell hair, you would go with the more common spelling, the more common definition of the hair on our head, H-A-R-I-R. So priming could kind of consciously or subconsciously influence our memory and how we retrieve information. So let's talk about a couple other tricks of retrieving information. There's context-dependent memory, context effects. If you take a test in the same room where you originally learned that material, you will do better. And so you are in luck this year because the AP test is usually given in the library. And this is the first year I am teaching AP Psych in the library. So that means that since you're learning the material in that room, you'll be more likely to remember it on the AP test. Maybe something as simple as you were staring off into space a little bit as I taught about the thalamus back in October, and you were staring at one part of the library. If your mind drifts there during the AP test, just seeing the same room, being in the same environment, might trigger your memory consciously or subconsciously. Right? So just another example of it where, depending on where you are and what you're thinking about, if you are in the place where the material is more relevant, you will learn it and remember it more quickly. We also need to talk about other things that help you remember. There is, let's do the second one first, mood congruent memory. So if you learn material in a certain mood, let's say you're really happy, you're more likely to remember it when you're happy. If you learn it when you're really angry, you're more likely to remember it when you're angry. This also plays a role into the perpetuation of our feelings. When you are feeling really sad, if you're feeling really down and depressed about yourself, and or about anything, you're more likely then to remember other instances of feeling depressed and interpret information in your environment as depressing. If you're happy, you're more likely to think about other happy moments. So happy begets happy, sad begets sad. It could be a vicious cycle, or it could be an amazing cycle if we're feeling good. So that could be, again, another great self-help technique to deal with our emotions. State-dependent memory. When we talk about state, we're not talking about New York, New Jersey. We're talking about the physiological state. Are we sober? Are we drunk right now? Are we high on one substance or another? It could be a drug like marijuana, or it could be a drug like caffeine. There's a tendency to recall experiences when in the same physiological state as when they were encoded. So all else being equal, let me just state, being high and being drunk damages your memory in many other ways. But there might be some things that if you first learn them when you're under the influence of marijuana, you may remember them better the next time you're under the influence of marijuana. But all else being equal, don't get any ideas. For our class, you will do best on the AP test if you are sober when you learn the material and sober on the day of the AP test, I hope. All right, final thing for today, serial position effect. If I read a list of names to you, you are more likely to remember the first or the last name. So serial position means remembering the beginning or the end of a list. There's two subcategories of that, which are really saying the same thing. The recency effect means that you're recalling the last items on the list, and the primacy effect means you're recalling the first items on the list. That's easy to remember. Recency is like recent, the last things. Primacy is like prime, like the first ones. But again, both of those refer back to the serial position effect, that you're not going to remember names 5 through 10 on a list. You'll remember 1 through 4 and 11 through 15 if I read you a 15-item list perhaps. All right. Thank you, everyone. I hope everyone has a great day and a great evening.